Our following speaker has more than 15 years of experience in IT and cybersecurity. He is currently engaged in the cybersecurity community across different countries and industries. He holds a university degree from Freiburg University in computer science, specializing in AI and psychology. Speaking about advancing in the speed of AI, please welcome Hans Borst, EMEA CTO, Vectra.AI.
Thank you. Welcome, everyone. The biggest hurdle, I think, the steps. We're talking about AI today and how to advance in the speed of AI. What do you need to know in addition about me? I think I love to look at technology at the intersection with the human. That's what I was able to look at also during my studies with psychology. And I also managed to apply AI already within the context of my previous life as a cybersecurity leader. And I hired a data scientist in 2017. We built our own AI models, so we put it into action and we put it into play. And today I wanted to bring you along on this journey to equip you with some understanding and knowledge, so to challenge vendors, like the one I'm working for and others, but also yourself in terms of what is it that we can and want to achieve with AI. To start with, in the end, the strategic advantage of AI is defined by the outcome it produces. I think that probably doesn't come as a surprise. However, the outcomes is something, that from our perspective, from my perspective, very much, most of the time, focuses on the interface between human and machines. And how do you realize these outcomes? It's all about trust. Trust is what makes the difference here. And this trust needs to be managed on both sides. It needs to be managed by the vendors, it needs to be managed by you. We need to build that rapport and we need to build the trust around it. So looking into this, I just wanted to give a quick intro so that we're on the same page. And maybe, if I may invite you just by a show of hands, how far do you think we are away from self-aware AI? If you want greater than 20 years away, anyone for this one? Within the next 20 years? Or did it already happen? It already happened? I don't know, maybe someone actually leaked my slides and looked into this. Of course, it was a trick question. Why is it important? Because movies and stories, they influence very much on how we look at AI. This is what we have, most of us, in mind when it's about AI. And most of them, they actually focus on the bad things and the fear that it may instill and the changes that it will drive. This is something that makes it so much harder to look into AI with an open mind and see what are the benefits that we can take out of it. So modern AI really is about machines that produce rational outcomes. It's not so much about cognition, right? When you look at this, of course, from a scientific way, you want to look into the nerve system, a human being. We want to rebuild in terms of what we're capable of processing. But for those ones of you that had the opportunity to look into the complexity of a human being, will realize that this is a very, very hard task. Still, there is many years of research into making this happen and actually converging towards what it is. But in the end, it's all about rationality. We heard it yesterday already, we heard it today. It is about defining a performance measure and success. So the agent, the AI, is always looking to gain the most out of this based on the environment it knows, inputs that it receives, and it does sequences. I think at the very beginning yesterday, we heard the great examples about the boat that was circling around just because it realized, okay, that's the gain. But as a human, you quickly realize that this is not necessarily producing the outcome that we wanted. So this means, in essence, just having AI is a necessary but not sufficient condition for a transformative outcome. So we need to use AI, but it's something that we need to be able to understand and to control. So if we look at AI, what is it actually when we're talking about AI? I think everyone agrees when we look at generative adversarial networks, producing people that do not exist. I mean, this is already there for some time. This is really something that is mind-blowing, that you look at those pictures and you see people that look like real people, but they don't exist. But at the same time, and this I think that came up over the last 12, 18 months, you can actually prompt machines and they create visuals that are also unique. This is also something that is very exciting to see, that you describe something and the machine is creating a response and you have an image like this. But at the same time, from a scientific point of view, this is also AI. A simple reflex agent that has a sensor, that has some condition rules to deal with the input that he's getting, and then creating an output, changing the environment or changing the state within the environment. It's a very simple model, but it's also considered part of AI. So thinking about this further and looking at this from a business perspective, when you talk to people, they're always like, yes, but we hire all of the data scientists and they build the great AI, or you get a vendor, they have a great AI. But then if you look under the hood, in most of the cases, it is actually more a simple model, similar like the reflex agent, rather than more complex models. Because it's so much harder to actually get into this direction. So what is important for us to agree upon, there is a different level of sophistication and capability when it comes to AI. So probably most of you will agree, a generative adversarial network, this is what we consider AI. A lookup table reflex agent or automation, probably not AI, but still, of course, something that falls into this category. So based on these grounds, we now need to see, and we heard this, how do we evaluate the outcome? Because yes, we want to gain something, but at the same time, we also need to make sure that we're not failing or that the algorithm is not failing. And I just wanted to give you also a few examples on what this means. And I'm going again with the image recognition, which is interesting also from a human perspective, because if you look at those pictures, you don't see a complete object. But every one of you will say, okay, well, the first one is a bus. The second one, even though hard to recognize, is a bird, and you have a temple. However, as a human, we actually don't know that this is a bus. We're guessing. We're guessing based on our experience, based on our knowledge, because, maybe that is just the front of a bus, but behind someone actually attached it to a truck or to something else, and this might be a bird that has a back part that is a lion or something like this. So we're guessing it because we're very efficient creatures, so we're guessing all the time. And we need to train our agents, our AI models, and they will be able to also recognize these kind of things. Now the funny part comes, because we look at this, we see a picture. If you have an AI, they look at this on a different level, because they're looking at each and every of the even invisible information and trying to categorize this. So the machine sees differently than we do. It's like a dog. A dog sees different than we do. Many animals, they see differently than we do. So if you actually create invisible information, you add it to the picture, what happens is the machine will say, oh no, this is an ostrich. That's probably also an ostrich. And that as well. So by simply actually altering the information, we just confuse the hell out of the machine. But for us, that's not visible. We don't see the difference in there. And it goes even further. You can do this in the physical world as well. You can just add some stickers to signs, and immediately the machine is not able to recognize this anymore. So that you imagine the impact of this. And there is also research that people that wear certain T-shirts with a print on it, so that it wouldn't be recognized by face recognition in a CCTV context. And the only thing you need to do is you need to wear a T-shirt. And here in this case, you just need to put a sticker on the sign. So what I'm trying to say is that we need to understand, we're talking about rational outcome. AI enables us to be transformative, but it doesn't guarantee it. And we need to measure the capabilities that help us to success, but also the resilience to failure. It doesn't help us if the system fails then all the time. So when we're applying this to cyber, right, we're looking into risk. We have likelihood times magnitude, and that creates a material impact. Usually if you invest into a technology, or let's say in general into mitigating control, you want to have an investment that is not $1 for $1 risk reduction. You want to have an investment of $1 that gives you a greater magnitude of risk reduction. And the investments that you take are usually time, effort, and resources. So looking into this, in this world, we as the human, we are the rational agent. We spend time, we spend our resources, we spend our skills. And when we applying this to a specific subset of cyber, defense cyber, of course we can look into the mean time to response, the total cost of ownership of your technology stack, the personnel, if it's ready. In a lot of cases, you also need to look into the health of the personnel because of the workload and potential symptoms of burnout. So these are the things that we can address. And when you look at this, and before diving any deeper, just also, thinking about, okay, whoa, this sounds very complex and very complicated. Let's talk about calculators. Everyone knows a calculator. My question to you is, did a calculator replace a mathematician? And I think everyone can answer this question. I think if you take that with you and say, okay, we're not talking about something that is here to replace a human. It's something that augments the human. So if you're looking at the human, we're all about ethics, culture, operational ambiguity, because we can switch and go back forth. But models in AI, they are specifically built, they're purposely built for a specific use case. You cannot just apply to different use cases. It doesn't work like this today. However, a machine has a different level of speed. Also, a concrete example, think about your short-term memory. How many items the average human can keep in his or her short-term memory? Talking 7 to 8 items. A machine can easily outperform you on these kind of things. So if you think about cyber, if you think about cyber investigations, you need to have so many information in mind. This is where the machine comes to play. So putting all of this together, offloading tasks, think calculator, to a human and to an AI will make the difference here. So if we give actually, and we have the right AI, we can supplement the human, enable the human, make the human more effective, having them focusing on value-adding outcome. And if we coordinate this well, we can use the strengths of both sides of the story. So how do we maximize this outcome that we want to achieve? So we have, of course, what we want to achieve with AI. We have the capabilities that the different AI approaches provide, which is our potential. And the realization is, as I mentioned it very early, linked to trust. Trust given by us, trust that the solution or the model earns, or the partner that you're working with. So if we bring all of this together, we're looking at the realized potential that we want to, of course, maximize in this context. So there's two different ways of looking at trust. So you can see if you give too much trust, the solution itself, should have a different trust level. And the best example is probably automated cars. So there's a vendor, I won't name it, that actually says, okay, I have a fully automated car. The people trust into it. We have already seen cases where they were watching a movie while the car was driving and they didn't control it. That is a most proper example of giving too much trust to something that hasn't deserved it yet. The other way around, we see this a lot, especially also within the security context. There is much more trust we can and should give to a solution, but we don't. Because we don't understand necessarily the impact. We might be afraid of this, so we create ourselves barriers around this. So it's a constant balance between these two things to make sure that we are building this trust, and moving in between the two extremes, so that we are moving forward and actually take the strategic advantage out of this solution. What is important in this case? Hold your partners and vendors accountable. They need to help you to actually gain their trust. They need to be measured in terms of making sure that their solution is trustworthy and doing this kind of things. And there we need to step up. So in conclusion, maybe also, to give you a little bit an idea about these kind of things. So when I started driving with a car, navigation was with a map made out of paper, right? Or you had a navigator next to you that was doing this for you. Nowadays, I think that for most of us, we use a GPS system, we use software. Different means of doing this, different software out there. We fully trust the software. Maybe as I think there is always, of course, I think more prevalent with men. We usually argue with the GPS because we think we know it better. But in general, we trust. And it goes as far as that there is incidents, people running their car into the river because the GPS said, no, you can cross the river. Unfortunately, they forgot that there's a ferry that they need to wait for, so they went a little bit fast. But in general, we're actually using this. It navigates us around the traffic, if we're lucky, and we're happy to do this, and we're not necessarily challenging this. So what I want to leave you with is, when you think about all of this, what is it that I ask you to think about and ask you to do is to apply the right level of velocity, the right level of speed to that problem. And there's the famous analogy which comes more from the evolutionary theory and the biology, in terms of how do you keep up to make sure that you're not falling behind and basically become irrelevant. And here we're talking about the analogy of the Red Queen's race, where it's really about finding the right pace to stay relevant and not falling behind and moving forward. And if you remember, I was telling you, there's organizations, there's people that looked into this, applying this in their business context already some years ago. This year, AI, and mainly large language models and generative AI, is very present, but it's not a new topic. So what I ask you and invite you to do is to come talk to us. We're outside there, right in front of the room, and see on how we can enable you to gain speed and have the right pace in terms of moving forward when it comes to cybersecurity and apply AI that is already out there for several years to your advantage. And on that note, I'll leave you with this. Maybe some of you want to discuss this any further. Thank you for your time and enjoy the rest of the conference.